Hello students, this is the second lecture on resultant of space force system. In the previous lecture, we had covered the problems on resultant of concurrent force system, including the problems based on general principles, general concepts, right? Now we are moving to type 2, that is resultant of general force system. Now, resultant of general force system is found based on force coupled system concept of coplanar forces. Now here, if you look at this diagram, here we have shown forces F1, F2, F3, F4 forming a general force system. General force system means what? Non-concurrent, non-parallel force system is called as general force system. So we forces F1, F2, F3, F4 are non-parallel and non-concurrent force system. So first of all, you need to write all the forces in vectorial form. So F1 bar, F2 bar, F3 bar, F4. Now, resultant of general force system will have two components. One is resultant force and another is resultant moment. Resultant force will be algebraic sum of all the forces in the vectorial form. So resultant force will be R bar will be F1 bar plus F2 bar plus F3 bar plus F bar, or you can say sigma F bar. All right. Now, resultant moment, resultant force does not change. Resultant moment will depend upon the point where resultant is required. If they don't give anything, we find the resultant force and resultant moment at origin O. Or else, if they have given mentioned the point where the resultant is required, we find the resultant at that point. Like, for example, we suppose the resultant of general force system is required at point O. So resultant force will be F1 bar plus F2 bar plus F3 bar plus F4 bar, or summation F bar. Resultant moment at O will be moment F1 about O plus moment of F2 about O plus moment of F3 about O plus moment of F4 about O. That means sigma MO. That means algebraic sum of the moment of all forces about the point O. So this will be the answer, second part of the answer. So a resultant of general force system will have resultant force and resultant moment. Now suppose we assume that resultant of general force system is required at A. So resultant force does not change. Resultant force will remain same. What is that? F1 bar plus F2 bar plus F3 bar plus F4 sigma F bar, as it is when resultant was required at point O. But resultant moment will change. What will be the resultant moment at A? You'll have to take algebraic sum of the moment of all the forces of the system about A. So moment F1 about A plus moment F2 about A plus moment F3 about A plus moment F4 about A. Or you can say sigma M. So resultant of general force system answer will vary depending upon the point where the resultant is required, as we have understood with this explanation. So resultant force does not change. Resultant moment will be sigma M about the point where resultant is required. Ready to start with the sums? First sum. Question number 1. Determine the resultant force and couple moment at point A. Point A, coordinates 3, 1, 2 of the following force system. You have given F1 bar 5I plus at 8K in Newton, acting at point B 831. F2 bar 3I plus 2J minus 4K acting at point O 0, 0, 0, and moment in vectorial form 12I minus 20J plus 9K. Students, we listed out in the solution. F1 bar is 5I plus 8K acting at point B. Coordinates 8, 3 minus 1. F2 bar is acting, F2 bar is 3I plus 2J minus 4K acting at point O, that is 0, 0, 0. What is M moment? Some external moment is given in vectorial form 12I minus 20J plus 9K. Now, students, in this case, he is asking you to find out the resultant force and resultant couple moment or resultant moment at point A. So resultant force at A will be F1 bar plus F2 bar. There are only two forces in the system, so you have to just, and they are already given to you in vectorial form, so you have to simply sum them up. F1 bar plus F2 bar, that becomes the resultant force at A. So that if you F1 bar plus F2 bar, if you do it, 8I plus 2J plus 4K. This is your one answer. Second answer will be what? Resultant moment at A. Resultant moment means A means what? Sigma MA. Sigma MA means what? Moment F1 about A plus moment F2 about A plus M bar. Moment is external moment. Nothing is to be done. It is simply to be added up to the sigma MA part. All right. Now we'll find first. So what will be that? M bar will remain as it is. Moment F1 about A means R1 cross F1. Moment F2 about A is R2 cross F2. R1 bar is position vector of point B with respect to A. So B minus A. B minus A. So B is 8, 3, 1. A point coordinates are 3, 1, 2. So B minus A is 8 minus 3, 5i. 3 minus 1, 2j. Minus 1, minus 2, minus 3k. Next, R2 bar. R2 bar is what? Position vector of O with respect to A. O minus A. 0 minus 3 minus 3i. 0 minus 1 minus 1j. 0 minus 2 minus 2k. Now we find moment of F1 about A. ijk. These are the coefficient of position vector. 5, 2 minus 3 and 5, 0, 8 are coefficient of force vector. You get it like this. Moment F2 about A, ijk. This is R2 bar and this is F bar. You get it like this. Resultant moment at A will be what? M bar plus moment F1 about A plus moment F2 about A. You add them up, you get the resultant moment. In the bracket, you should write the units. So in this problem, we understood that resultant force or resultant force of the general force system is write all forces in vector form, sum them up, irrespective of the point where resultant is required. If the resultant is required at point A, it is resultant moment is sigma m. That is moment F1 about A, moment plus moment F2 about A, and plus m bar, that was external moment in the sum. Now we move to the second sum, where we'll have to write the coordinates also. We have to, then only we'll be in a position to put the forces in vectorial form. Concept, procedure, methodology will remain same. Let's read the sum. A rectangular parallelepiped carries 4 forces as shown in the figure. Reduce the force system to a resultant force applied at the origin and moment around origin. That means you have to find the resultant of the given general force system at point O. Resultant will have two components. One is resultant force and resultant couple moment or resultant moment. Right? Now there are 4 forces which are appearing on the diagram: 10 kilonewton, 7.07 kilonewton, 4 kilonewton, and 8 kilonewton. All right. You have to name these forces. How I am naming the forces? F1, 8 kilonewton is called as F1, 4 kilonewton is being called as F2, 7.07 is being called as F3. All right. And 10 kilonewton force is being called as F4. It is necessary to name the forces because then only you can take them into the working. Now the diagram has been done. Same diagram has been drawn. Now we need to write the coordinates of various points where these forces are passing. Students, it's a 3-dimensional figure. This is x-axis, this is y-axis, this is z-axis. So first we write the coordinates of point which are lying on the axis, like point A. Point dimensions of this box. OA, this length, this dimension length of the box or dimension of this box along x-axis is 5 meters. All right. OB, height of the box along y-axis is 2 meters. OC, dimension of the box along z-axis is 4 meters. So now we write coordinates of point A. This point is lying on x-axis, so its coordinates will be 5, 0, 0. Point B is lying on y-axis. Height of the box is 2 meters, 0, 2, 0. Point A is lying, point C is next point is C, which is lying on z-axis. So this dimension of the box is 4 meters, so 0, 0, 4. All right. After that, we'll write the coordinates of point D. Point D is lying in xz plane. Point D is lying in xz plane, so y coordinate is 0. X coordinate is 5, y coordinate is 0, and z coordinate is 4, 5, 0, 4. All right. After that, we come to point E. Point E is lying in xy plane. So z coordinate is 0, x coordinate is 5, y coordinate is 2, z coordinate is 0, 5, 2, 0. Then we come to point B. Point B is already written, sorry. Point F. Point F is lying in YZ plane. Any point lying in YZ plane will have x coordinate 0. So 0, height is 2 meters, and this is 4. 0, 2, 4 will be the coordinates of point F. Then we come to the coordinates of point G. G point, although we don't need it, coordinates of point G will be 3 dimensions of the box. X coordinate 5, y coordinate 2, and z coordinate 5, 2, 4 will be the. Now we have to start writing the forces in vectorial form. Force F1 is 8 kilonewton. Is it parallel to y-axis or not? If force F1 is parallel to y-axis, unit vector parallel to y-axis or along y-axis is j. So this will be in positive direction. F1 bar will be plus 8j. F2 bar. F2 bar force is acting along x-axis in negative direction. Can you see that here? It is all the more clear. F2 is 4 kilonewton, which is acting along x-axis but in negative direction. So this will be minus 4i parallel to x-axis. Then we come to force F3. F3 is acting from B towards D, right? So 7.07 into lambda BD. BD means D minus B. D minus B. D is 504, D is 020. So 5 minus 0, D minus B. 5 minus 0, 5I. 0 minus 2, minus 2J. 4 minus 0, 4K. Right? Divided by mod of it, then you get the F3 bar. F4 bar. F4 bar is acting from O towards F. Coordinates of point F are 0, 2, 4. O is 0, 0. So F minus O. Right? 0 minus 0, 0I. 2 minus 0, 2J. 4 minus 0, 4K. 2J plus 4K. All right? Then divide by its mod. Then you get the force in vectorial form. This way, four forces F1, F2, F3, F4 are obtained in vectorial form. So resultant force at O will be, or at any other point, here it is required at O. So resultant force at O is F1 bar plus F2 bar plus F3 bar plus F4 bar. Add them up in vectorial, right? IJK coefficients are added, you get the resultant. Resultant is obtained as 1.27I plus 10.362J plus 13.164K. And units in the bracket, that is kilonewton, that is your first answer. After that, you have to find resultant moment at O. Resultant moment at O means what? Sigma MO. Sigma MO means what? Moment of F1 about O plus moment of F2 about O plus moment of F3 about O plus moment of F4 about O. But out of these four forces for which you will be taking moment about O, we should observe that is there any force passing through origin? Yes. Can you see that? F2 force is passing through, 4 kilonewton is passing through origin, and F4 force, which is of 10 kilonewton, is acting at O only. So F2 and F4 will give zero movement about O. Since they are passing, F2 and F4 force will be giving zero movement about O since they are passing through O or origin. So these two will go off, which we can show it like this. I have shown it movement F2 about O, so that indicates they are zero. So you are left out with movement F1 about O plus movement F3 about O. Movement F1 about O is R1 cross F1. Movement F3 about O is R3 cross F3. R1 bar is what? R1 bar is movement, position vector of point A or E. We have 2 points, A or E. So we'll take position vector A with respect to O. So that is 5. R3 bar is you have the option of taking B or D. B point also, B point has one coordinate, D point has two coordinates. So we should select, see, we can take position vector of any point on the line of action of the force. So you should prefer the point which has lesser coordinates. In this case, I should prefer B point, not D. B point position vector of B with respect to is 0I plus 2J plus 0K. So that is 2J, right? So here I have written a note also, same what I was telling. While selecting any point on the line of action of the force, we should select the point with less number of coordinates. So movement of F1 about O, IJK, this is R1 bar and this is F1 bar. So you get it 40. Movement of F3 about O, IJK, 0 to 0, and this is in the third row. What do you get it? F3 bar. Then if you solve it, you get like this. So then resultant movement O is movement F1 about O plus movement F3 about O, and you get it. Resultant movement at O is 8.44I plus 29.46K. That is kilonewton. Hope this is understood. Okay. Now, students, we come to the third problem. I'm reading it. Here, coordinates are given. A weightless box of size 3 by 4 by 2 meter is loaded by 3 forces as shown in the figure. Find the resultant of all the forces at the origin. Also find the vector movement about the diagonal OB due to the 3 forces. He's asking resultant of all the forces at origin. That means you have to find the resultant of given general force system at O. That means that you have to find not only the resultant force, you have to also find the resultant movement. Don't think that here said find the resultant, so you'll find only resultant force. That is incomplete. Resultant of general force system has 2 components, resultant force and resultant movement. Well, now come to the given diagram. Here we have 3 forces. This is 20 kilonewton to the right, 20 kilonewton to the left, and 60 kilonewton upward. You have to name them. F1, 20 kilonewton towards right, I have named as F1. 20 kilonewton towards left, I have named it as F2. 60 kilonewton upward has been named as F3. All the 3 forces are parallel to standard reference direction, so you can write them in vectorial form directly. F1 bar, this 20 kilonewton is parallel to y-axis, so in vectorial form it will be plus 20J. This 20 kilonewton is parallel to along y-axis, but in negative direction, minus 20J. 60 kilonewton is parallel to z-axis in positive direction, plus 60K. So resultant at O will be F1 bar plus F2 bar plus F3 bar, and this comes out to be plus 60K. In the bracket, we have written the units, kilonewton. All right. Found the result. Now, what will be resultant moment at O? Resultant moment at O means moment F1 about O plus moment F2 about O plus moment F3 about O. Out of the three forces F1, F2, and F3, you can see that 20 kilonewton force F2, it is passing through origin, so its moment will be 0. This we have marked it here. Moment F2 about O is 0. Right? Then we have to find moment F1 about O, that is R1 cross F1, and F3 about O, R3 cross F3. Now, coordinates of the points are directly given in the sum. As coordinates of point C, it is 0, 4, 0. As it is in YZ plane, X coordinate is 0. Y coordinate, that is height of the box is height of the box is 2 meter. Length of this Y dimension of the box is 4 meters, 0, 4, 2. All right. Point F is lying in XY plane, so Z coordinate is 0. X coordinate is X dimension of the box is 3. Y is 4, 0. And point B will have 3 dimensions of the box, that is 3, 4, 2. All right. These coordinates are given also. Sometimes in the problem, examiners give you the coordinate directly also, as in this problem were given to you. Even if they were not given, still we could have found the coordinates. All right. Now, we need to write coordinates of point D also. Coordinates of point D, as it is lying on Z axis, it will be 0, 0, 2. Any point lying on the Z axis will have a X and Y coordinate 0, 0, 0, and that is 2. All right. Now we'll take up R1 bar. R1 bar is position vector of D with respect to O. So that is 2K. R3 bar is position vector. For this force, you have the option of taking F or B. For force F3, you have 2 points on its line of action, that is F and B. F has got 2 coordinates, B has 3 coordinates, so we'll prefer F. So R3 bar is position vector F with respect to O, that is 3I plus 4J. Then we calculate moment of F1 about O. IJK, this is R1 bar, and this is F1 bar. So moment of F3 about O, IJK first row, second row R3 bar, third row F3 bar. So you get this. Then resultant moment at O will be moment F1 about O plus moment of F3 about O. As moment F2 about O is already 0. So you got the answer. This is nothing but resultant moment at O, or we can call it as sigma MO also. So moment of all the forces about OB. Now next part, second part of the sum, which is asking also find the vector movement about diagonal OB. So he's asking movement all the forces about OB. So what it is going to be? Dot product of unit vector along the line. It will be equal to the dot product of unit vector along the line and sigma MO bar. That means algebraic sum of the moment of all forces about O. Sigma MO bar is already ready with me. Sigma MO bar is already ready with me. I have to only find lambda OB. Lambda OB means what? B minus O. B minus O. O is 0, 0, 0. B is 3, 4, 2. So 3I plus 4J plus 2K divided by its small. You get lambda OB. So movement of all forces about OB, lambda OB, you write this value 0.557I plus 0.743J plus 0.371K. Dot sigma MO. What is that? 200I minus 180. So you get the answer in vectorial form minus 22.98 kilonewton meter. So here this answer is in scalar form. You have to get the answer in vector form. So vector movement of all forces about OB is what? That is magnitude of this, but minus 22.98 into lambda OB. Lambda OB value can be substituted from here. You will get the vector movement of all forces about. Right. So in this problem, first part of the problem was finding the resultant of general force system, and second part of the problem was involving vector movement of all the forces of the system about OB. So we use the result of the first part to get the vector movement of the forces of the system about diagonal. Now we come to the fourth problem of the resultant of general force system. There is nothing new in this problem, as this is already we have covered. All right, it is an additional practice problem, we can call it. Now we are reading sum. As in the first three problems, all concepts have been already covered. All right, but still I'm taking one more problem to make you understand the concepts. Determine the resultant of the force system shown in the figure. F1 is 150 Newton, F2 is 120 Newton, F3 is 200 Newton, and F4 is 220. F1 is acting as in the diagram from A towards E. F2 is from A towards C. F3 is from E towards D. F4 is from B towards A. F1, F2, F3, F4 magnitudes are A. All right. Now coordinates of various force systems. This dimension is 3, this is 3, and this is 4. So we need to write coordinates of various points. First, we write the coordinates of the point lying on the reference axis. As origin is 0, 0, 0, coordinates of point A lying on x-axis will be 3, 0, 0. Coordinates of point C lying on y-axis is 0, 3, 0. Coordinates of point D lying on z-axis 0, 0, 4. All right. Then coordinates of point B, it's lying in xy plane. All right. It's lying on xy plane. So z coordinate will be 0, 3, 3, 0. Then we come to point D. Point D is lying in yz plane. X coordinate is 0. Y coordinate is 3 and z coordinate is 0, 3, 4. All right. So I think this way we have written the coordinates of all the points. Now we can put the forces in vectorial form. Let can see that F1 bar is 150 into lambda A. Lambda A means AE upon mod of A means E minus A. A means E minus A. So E is 004. A point is 300. So 0 minus 3 minus 3i, 0 minus 0 0j, and 4 minus 0 4k. So minus 3i plus 4k divided multiply. F2 is 120 lambda AC. 120 lambda AC. All right. F2 magnitude is 120. Lambda AC means AC upon mod of AC. AC was C minus A. C point 030. A is 0. 0 minus 3 minus 3i. 3 minus 0 3j. 0 by 0 minus 3i plus 3j divided by mod, you get this. Force F3 is parallel to y-axis on positive side. What is that? F3 bar is going to be, F3 magnitude is 200. So plus 200j. F4 is parallel to y-axis but negative direction. So F4 minus 220j. So this way we could write all the forces in vectorial form. In this problem, they have not mentioned at which point resultant is required. So we'll find the resultant at origin. So right, we assume that resultant, we are finding the resultant at O. So resultant force at O is F1 bar plus F2 bar plus F3 bar plus F4 bar. You get the resultant at O. Resultant moment at O is what? Sigma moment of F1 about O plus moment F2 about O plus moment F3 about O plus moment F4 about O. Or you can call it as sigma MO also. None of the force is passing through the origin. So all the forces will generate the moment about O. Moment F1 about O, R1 cross F1. Moment F2 about O, R2 cross F2. Moment F3 about O, R3 cross F2. Moment F4 about O is R4 cross F1. Now you can see that here also we try to simplify as suppose 2 points are given on the line of action of the force. So we write the coordinates of a point which has lesser number of coordinates. Now here you can see that point A. At point A, which forces are passing? F1, F2, F4. So at point A is having only one coordinate since it's lying on x-axis. So I can say that R1 bar, R2 bar, and R4 bar are equal. R1 bar is equal to R2 bar is equal to R4 is equal to position vector of A with respect to O. So simply you get it 3i. With respect about the force F3, you have the option of taking E or D. So we'll take E point because E is lying on z-axis will have only one coordinate, right? So R4 bar, R3 bar is equal to position vector of E with respect to O, that is 4k. All right. Now you can easily find moment F1 about 2 ijk. This is R1 bar. This is F1 bar coefficient. Moment F2 about 2 ijk first row, second row, R2 bar, third row, F2 bar. Moment F3 about 2 ijk. This is your R3, and this is your F3. Moment F4 about 2 ijk. This is coefficient of R4, and this is coefficient of F4. Sum them up. Moment of F1 about O plus F2 about O plus F3 about O plus F4 is resultant moment at O. This is the answer of. So again, I repeat that resultant of general force system will have two answers. One is resultant force, another is resultant. Resultant force does not change; it remains same irrespective of the point where resultant of general force system is required. But resultant moment will be algebraic sum of the moment of all forces system about the point where resultant is required. So, okay, students, now we are ready to move to the next type, that is type 3, resultant of parallel force system. Let's understand how do we find resultant of parallel force system. Now, you can see that in this problem, this diagram over here, I have shown 4 forces F1, F2, F3, and F4 forming a parallel force system in space. First, you will write all the forces in vectorial form, which will be quite easy because the forces, all the forces will be either parallel to y-axis or parallel to x-axis or parallel to z-axis. So writing the force in vector form will be quite simple. You have got resultant force. Then resultant, then you have to find position of the resultant. Position of the resultant in parallel force system is found using the Verignos theorem as we were using in parallel for in the problems of resultant of parallel force system in coplanar force system, right? So what is, suppose you want to find positional resultant with respect to O. So we'll write Varigno's theorem with respect to O. What is that? Sigma MO is equal to moment of resultant about O. Of course, bar will be there. So sigma MO bar, it is in form of vectors. Moment resultant about O, that will also be in the vectorial. All right. So this is the way, I mean, you should remember that resultant of parallel force system in space is obtained using Varigno's theorem. Let's start with the problems. Type 3. I read this. A square foundation mat supports the 4 columns as shown. Determine the magnitude and point of application the resultant of the 4 loads. Can you see that this is a foundation mat? It is of 10 by 10 meter. At O, there is a column on which load of 40 kilonewton is applied. This is 12 kilonewton applied at E, 8 kilonewton is applied at D, and 20 kilonewton is applied at E. All right. All positions of the columns are defined in the diagram. All the loads are parallel to y-axis. We draw another diagram. We call force 40 kilonewton force is named as F1, 20 kilonewton force is named as F2, 12 kilonewton force is named as F3, 8 kilonewton force is named as F4. So all the 4 forces can be written in vectorial form without it, because all they are parallel to y-axis. F1 bar will be minus 40J, F2 bar will be minus 20J, F3 bar will be minus 12J, F4 bar will be minus 8J. So all the 4 forces have been written in vectorial form. Resultant force will be equal to F1 bar plus F2 bar plus F3 bar. All right. So resultant, we have just simply add them up, minus 80J. If you add this, all are parallel to y-axis, so they are simply added up. So you get the resultant as minus 80J. 80J means was 80 kilonewton, and it will be vertically down, okay, parallel to y-axis in negative direction. Now, to find the position of the resultant with respect to origin, you will be understanding that movement of one force is 0. Why movement of F1 about O is 0 or not? Since it is passing through O. Since it is passing through O. Other 3 forces will give movement about O. So we'll apply Varigno's theorem about with respect to point O. Now let's write the coordinates, student. Origin will have coordinate 0, 0, 0. Point E is lying on x-axis, will have only x coordinate 10, 0, 0. Point B and D are lying in xz plane, y coordinate is 0. Coordinates of point A. X coordinate is 4, y coordinate is 0, z is 10. Point D. X coordinate is 10, y coordinate is 0, z coordinate is 5. 10, 0, 5. So these are the coordinates of various points. Now we'll apply Varigno's theorem, but we have to find moment of F1 about O is 0. Now we'll find moment of F2 about O. Now let's turn to the next page. Now, movement F2 about is R2 cross F2. R2 bar is what position vector of D with respect to O. Coordinates of point D were 4, 0, 10. So it is 4i plus 10k. So movement F2 about O. The movement F2 about O. It's ijk. These are R2 bar 4, 0, 10. And this is force and vector F2 bar coefficient. So then movement F3 about O is R3 cross F3. What is going to be R3? Position vector of point C. It is acting at point C. It is lying on x-axis, as we already explained to you in the position of point F3. F3 point, it is a position vector of point T, 10, 0, 0. Position vector of E point with respect to O. Right? This is 10i. Then movement F3 about O, ijk, 10, 0, 0, 0 minus 12, 0. You got minus 120. Movement of F4 about O, that is R4 cross F4. R4 is position vector of the point where this force is acting. All right. The coordinates of the point where this force is acting is 10, 0, 5. Force F4 is acting at point D. All right. It is the position vector of this point will be 10i plus 5k. F3 is acting at point E, so this is position vector of point E with respect to O. This is 10, 0, 0. F2 is acting at point B, so coordinates position vector B with respect to O is 4, 0, 0 or 4i, you can say. All right. Then you get sigma mo, moment f1 about 2 plus f2 about 2 plus f3 about 2 plus f4 about 2. You add them up, you get it. Let us assume that resultant passes through a point f with coordinates x bar 0 z bar. That I'll show it to you again. In the diagram, you can see that we are assuming that resultant is passing through point O having coordinates x bar 0 z bar. So position vector of this point f with respect to O will be x bar I plus 0 j plus z bar k. So moment of resultant about O will be I j k. This is going to be I j k x bar 0 z bar 0 minus it is 0, so it comes like this. Using Varignus theorem, sigma mo bar is equal to moment resultant about O. Sigma mo bar we wrote it on left side, which we got it from here. 240i minus 240k is equal to moment resultant about O 80 z bar I minus 80 x bar k. Equating the I and k coefficients, you get x bar and z. All right. So we are ready to move to the next problem. Now let's same type of sum. Almost identical steps will be followed. Forces of 20 Newton, 10 Newton, and 30 Newton are shown parallel to y-axis. All forces are parallel to y-axis. That is appearing also in the diagram. The forces are acting in xz plane at coordinates xz are 2, 3, 4, 2, and 7, 4. 2, 3, 4, 2, and 7, 4, which are marked also in the diagram. Determine the resultant and locate its position. We need to name the forces. 20 Newton force has been named as F1. 10 Newton force has been named as F2. 30 Newton force has been named as F. F1 bar is equal to plus 20j, since parallel to y-axis in positive direction. F2 bar is minus 10j. F3 bar is plus 30j. So you got F1, F2, F3 in vectorial form. Resultant force is F1 bar plus F2 bar plus F3 bar. You get it 40j or 40 Newton vertically up. Now we need to find the position of the resultant with respect to O. So we'll apply the Varignus theorem with respect to O. I assume that first we need to write the coordinates of the point A through which F1 20 Newton is passing. So he has given X and Z coordinates. So, but we should write it X, Y, Z, 203. Point B at which F2 force of 10 Newton is acting. So 402. F3 force is 74704, 30 Newton. And I assume that resultant is passing through a point D having coordinates X bar 0, Z bar. Why X bar 0, Z bar? Because it is lying, it's acting on a point which is in xz plane. So its Y coordinate has to be 0, as Y coordinate of all other points in xz plane is also 0. So we will find moment of F1 about O is R1 cross F1. R1 will be what? Position vector of point A with respect to origin. It is acting at A with respect to A. So 2i plus 3k as origin is 0, 0. Then moment F1 about O, ijk 203, and this is 0 plus 20. The moment of F2 about O is R2 cross F2. R2 is what? Position vector of point B with respect to O. So 4i plus 2k. All right. The moment F2 about O, ijk 402 and 0 minus 10, 0 you get. Moment F3 about O, R3 cross F3. R3 bar is what? Position vector point C with respect to O. That is 7i plus 4k. Moment F3 about O, ijk 704, 0, 30, 0 you get moment F3 about O. Sigma MO is what? Moment F1 about O plus moment F2 about O plus moment F3 about O, or we can call it as sigma MO also. You got it. Then moment of R bar about O. Moment resultant about O is R bar cross R bar. Right? What is R bar? Position vector of the point D with respect to O. So X bar I 0j plus Z bar k. So we'll find moment resultant about O. Ijk X bar 0 Z bar 0 40. So you get. Now applying Varignus theorem, sigma MO bar will write on left side. Moment resultant about O bar we write it on right side. Equating the I and k coefficients, you get Z bar and X bar. So this way you get the coordinates of the point where the resultant is active. So in these two problems were of the state problems where the resultant of parallel force system was asked. Now in the next problem, resultant certain condition is given Based on that, we will be solving the sum. Let's come to the next problem. Okay. Let's come to the problem number 3. Determine the loads to be applied at A and F if the resultant of all the 6 loads is to pass through the center of the foundation of the hexagonal shape of the side 3 meter. Is given the foundation is this time in the shape of hexagon with the side 3 meter. With the side 3 meter. 4 forces at E, D, C, and B are given. At A and F, the forces are unknown, which you need to find out. So we name since the resultant of all the loads is passing through the center of the foundation. So we can say sigma MO is 0 or not. If I say resultant of all the forces is passing through O, that means resultant is passing through O means moment resultant about O is 0. Moment resultant about 0 means as per Verigno's theorem, sigma MO is equal to MRO. So that means sigma MO is 0. That means sigma MO is 0. Hope you all are understanding. This is important concept to solve this sum. This is important concept to solve this sum. I repeat again, the resultant of all the loads is passing through O. If resultant of all the loads is passing through O, moment resultant about O is 0. But as per Verigno's theorem, we understand sigma MO is equal to MRO. That means since MRO is 0, sigma MO will also be 0. Now I'm naming force F1 as 75 kilonewton, F2 as 125 kilonewton, F3 is 50 kilonewton, F4 as 100 kilonewton. F5 is the force which is acting at A, F6 is the force which is acting at F. All right. Now students, in the previous two problems, writing the coordinates was easy. In this problem, writing the coordinates is little difficult because we have to draw the hexagon in plan. I mean, you have to draw a two-dimensional figure, then you will be in a position to read X and Z coordinates of all the corners of the hexagon. I have drawn the regular hexagon in a plane. Then I have joined the diagonals. All these diagonals will pass through a point O, which is nothing but origin of 3 reference axes. So this is your x-axis in the plane. This is your z-axis in the plane. If this each side of the hexagon is 3 meter, so this is 1.5, 1.5, 1.5. Now, as per the geometrical properties of this regular hexagon, all this diagonal, half diagonal will be also 3 meter because it will reduce to a network of equilateral triangle. This is 3 meter, this 60, 60, so this also will be 30. So this is one equilateral triangle, another equilateral, so it reduces to 6 equilateral triangle. You can understand that this regular hexagon is made up of 6 equilateral triangle with side 3 meter. Equilateral triangle means all angles will be 60 degree. So we will find this dimension in this right angle triangle. This dimension is 3 meter. So this is 60. So this is 3 sine 60, 2.6 meters. Similarly, in this right angle triangle, all right, this diagonal is 3. So this height is 3 sine 60, 2.6 meters. So students, we need to write coordinates of all the points. As you can see that. Coordinates of point D lying on x-axis, 3, 0, 0. Coordinates of point A lying on x-axis but on negative side, minus 3, 0, 0. Then we come to point C. Point C is in xz plane, x coordinate 1.5 plus, y coordinate 0, z coordinates plus 2.6. All right. Then we come to point D. These are now point E. Point E is x coordinate plus 1.5, y coordinate 0, z coordinates minus 2.6. Point F, x coordinate minus 1.5, y coordinate 0, z coordinate minus 2.6. So F point will have both the coordinates. Now we can write moment of F1 about O. That is R1 cross F1. R1 is nothing but position vector of the point where this force is acting. This force is acting at point E. So this will be position vector E with respect to O. So E minus O. So whatever is the position coordinates of point E, same will become the position vector. E point has the coordinate 1.5, 0, 2 points. So 1.5 I minus 2.6. And F1 bar is minus 75 J because it is parallel to y-axis in negative direction. Now, moment of F1 about O, IJK. This is R1 bar and this is F1. You got moment F1 about O. Moment F2 about O is R2 cross F2. That is R2 cross F2. R2 bar is position vector of D with respect to O. This is force F2. This is position vector of point D with respect to O. That is 3, 0, 0 with the coordinates of point D. So position vector of D with respect to O will be 3i. Clear. F2 bar is 125 Newton. This is parallel to y-axis, so minus 25. You get moment F2 about 2. Okay. Then we come to moment F3 about 2. Moment F3 about 2. How do you find moment F3 about 2? R3. Just a minute. There is slight problem. Just a minute. Hold on, please. I'll continue in a minute. Okay. We continue with this. Now, we have found moment of F3 about 2. Now next, we have to find moment of F4 about 2, R4 cross F4. R4 is position vector point B with respect to, so coordinates of point B were minus 1.5, 0, 2.6. So coordinates of point O are 0, 0, minus 1.5 I plus 2.6. F4 is parallel to y-axis negative direction. So F4 in vector form is minus 100 J. So we write moment F4 about 2, IJK. This is R4 bar and this is F4. You get it. Moment F5 about 2, R5 cross F5. R5 is what? Position vector of point A with respect to coordinates of point A were minus 3, 0, 0. So position vector of A with respect to will be minus 3I. Then F5 is unknown. So we are considering the magnitude F5 in negative y direction. So F5 in vectorial form will be minus F5J. Then moment F5 about O is obtained IJK. This is R5 and this is F5. So you get it like this. Similarly, moment F6 about O, R6 into R6 cross F6. R6 bar is position vector of F with respect to O. Coordinates of point F, as already we got it, minus 1.5, 0, minus 2.6. So position vector of point F with respect to minus 1.5 I minus 2.6 K. So again, F6 force is unknown. So F6 bar will be minus F6J since F6 is acting in negative direction parallel to y-axis. So moment of F6 about O will be IJK. This is R6 bar and this is F6 bar. Then you get it. As resultant of all the loads is passing through point O, sigma MO will be 0. Right? Sigma MO means moment F1 about O plus F2 about O plus F3 about O plus F4 about O plus moment F5 about O and F6. All these are here in the screen. You can see that this is F1 about O, this is F2 about O, this is F3 about O, this is F4 about O. All right. This is F5 about O and this is F6 about O. Add them up and simplify it. You'll find it that I and K coefficients will be there. I and K coefficients are added up and equated to 0. So if I coefficient is equated to 0, you get F6 as 75 kilometer. And if K coefficients are added up and equated to 0, you get it as F5 as 100 kilometer. So this way F5 and F6 are arrived. So students, with this we have completed the 5th chapter of statics, right? As per Mumbai University syllabus, this is the there are total 5 chapters on statics. So all the 5 chapters have been completed in my video lectures. All right, and in all from with this lecture we have completed 8 chapters. Lectures have been completed. 5 chapters of statics have been completed, and we have also completed 3 chapters of dynamics. We are left out with 3 chapters of dynamics as per Mumbai University syllabus. That I'm likely to complete the syllabus of Mumbai University by the end of next week. Next, in 7-8 days time, I'll be surely completing the Mumbai University syllabus. And after that, we will be covering the syllabus of autonomous institutions like BJTI, SPC, KSH, Humaya, and all other autonomous institutions. Right, students? These video lectures are completely free. All right. Its QR code can be shared with your friends. I request you to share with your friends so that they are also benefited with my video lectures. All right. You are also requested to you can subscribe to my this YouTube channel so that you will keep getting the notification as the new video is uploaded. All right. You can buy the book if you want to refer to the more solved problems, right? Many more solved problems in each type are given in the book, right? Book is available in the local bookstores as well as on Amazon. All right. With Amazon, we have arranged the free delivery with certain discount also. My book is having MCQs also, which are going to be part of your examination in this semester. All right. Thank you very much.